there. Today we're going to be looking at Chapter 3. And Chapter 3 starts very similar to the way Chapter 2 did. We're going to be doing some work with difference in proportions and hypothesis tests. But Chapter 3 is all about independence versus the hot hand. So let's look at what those specific words mean. Okay? When we say a player has the hot hand, a player has the hot hand if his or her ability to be successful is higher following a success than following a failure. Okay? So that's what it means to have the hot hand. Okay? Basically, like every success kind of like helps you be more successful, right? Now, let's say that a player's ability to be successful is the same following a successful performance and an unsuccessful performance. What that means is that the player does not have the hot hand and what that means is that the results are what are called independent. So those are two different things, having the hot hand where the ability is greater after a success than a failure versus the being independent, which means it doesn't really matter, okay? So again, let's look at this idea of independent events, okay? Independent events are when the outcome of an attempt does not depend on the outcome of previous attempts, okay? Independent attempts, you can say one outcome does not affect the next attempt. Okay, so those are some ways to talk about independence. Okay, one of them is, again, this idea of the ability. So the ability to be successful is the same after a successful performance and an unsuccessful performance. We can say the outcome of an attempt does not depend on outcomes of the previous attempts. And we can say that one outcome does not affect the next attempt. So those are three different ways that we can talk about independence, okay? So all of those ways are ways to talk about independence. And you guys are going to talk about independence in homework number 2, I believe, okay? So homework number 2 is all about what it means to be independent, okay? So again, if two games are independent, then that means that the ability to win the second game is the same, regardless of if the first game is won or lost, okay? However, if a team has the hot hand, then that means the ability to win the second game is greater if the first game is won rather than if it was lost, okay? And so this is going to be very, these type of questions are going to be similar to homework questions number 1, number 2, and 3B. You can kind of use that as an idea, what it means to be independent versus having the hot hand, okay? So let's look at the 2014-2015 U of M men's basketball season. In order for us to kind of use the methods that we have before, the methods that we talked about in Chapter 2, what we're going to do is we're going to be looking for pairs of data. We're going to look at pairs of data, okay? So here are the results of Michigan's 33 games during the 2014-2015 season, okay? And we can see their different wins and losses. So here are the results of the different pairs of data. So this win-win is the first pair of data, okay? The next thing that happens is that we don't look at games 3 and 4. We would look at games 2 and 3. And games 2 and 3 tell us that that's win-win, okay? Then we would look at games 3 and 4. That gives us a win-win. Then we look at games 4 and 5. That gives us a win-win. Then we look at games 5 and 6. That gives us a win-loss. And then what we would do is just keep going, etc. Okay? And so when we do that, these end up being the pairs of data that we see. Notice that there are 33 games, but only 32 pairs of data. And that's because this 33rd game doesn't have anything to be paired with. Does that make sense? So the very last pair that we're seeing is this pair of 32 and 33. That's why there are only 32 pairs of data. Okay? All right, so let's summarize these results in what is considered a two-way table. And when we had the two-way table, what we usually did is we had the outcomes along the columns, or sorry, in the rows, and then the two contexts in the columns, okay? The thing is that our contexts are comparing what happened first, okay? So what happened if they won the previous game or won the first game, and what happened if they lost the previous game, or if they lost the first of the two games, okay? And we're saying what happened first, like did we start each pair with a W or did we start the pair with an L? The outcome then is what happened after that. So this is going to be what happened if they won the next game. So if they won the second of the two. And what happened if they lost the next game, or if they lost the second game, okay? And then of course these last are going to be just where we can add to find our totals, okay? So winning the first and winning the next means that we have a win followed by another win, WW. And what we can do is try to count how many times that happened. How many times did they win and then win again? And if we count the WWs, hopefully you guys are finding that there are 9 of those. Now then there are some games where they won the first game, but they lost after winning. And those look like WLs in our data. So we can count the different WLs that are in these pairs of data. And we find that there are 8 of those. There were some pairs where they lost the previous game, so they lost a game, and then after losing, they were still able to win the next one. And if we count the number of LWs, that gives us 7. And then there are times when they lost the first game, and then they lost again. So those are LLs. And if we count those, that's going to be 8. And so if we just do our different additions to get the different totals, we can see that both the rows and the columns add up to 32 pairs of data. Okay. And you're going to be making a two-way table like this in number 3A on the homework. Okay. And again, remember that like these right here are the outcomes. Ultimately, we're concerned with what happened second, right? And then we're trying to see if what happened first played a role in those outcomes, okay? So again, these are the two contexts that we're comparing. What happened first? Could winning first help us win again? Okay. So to see if there is evidence that Michigan gets a hot hand, we have to compare their performance after a win and their performance after a loss. So let's look at their performance after. I stopped recording, so. Okay, so we want to look at their performance after a win versus after a loss. So the performance after a win means that we're going to be looking here. If they, after they won the previous, what exactly is happening, okay? So I look to see that after a win, they were successful. They won 9 times out of the 17, okay? So again, after a win, they won 9 times out of 17, okay? And what happened after a loss? Well, after a loss, we would look here. This means they lost the previous game. And after a loss, they won 7 times out of 15. So there were 15 times that there was an L first, and 7 of those times there was a W that followed. There were 17 times that a W was first, and there was a win 9 times out of there, okay? So then we can find what those percentages are. So I'm going to take, oopsie. So I can take 9 divided by 17 and 7 divided by 15. And I can put those values as the different performances. And so I can see that this is going to be about 0.529. And this is going to be about 0.467. Okay. And so what we can see is that Michigan performed better after a win than after a loss. Okay. So to see if this data gives convincing evidence that Michigan gets a hot hand when winning games, we will run a hypothesis test. We're going to state the null and alternate hypotheses for the data on the Michigan basketball team. And we know our null hypothesis talks about the ability being the same. And what that really is that idea of independence. So our HO is going to be that the 2014-2015 U of M men's basketball team and we're looking at their ability to win. So our null is going to be talking about the same ability to win. And this time we're comparing what happened in the previous game. So we're comparing what happened after a win or a loss. Or you could put and a loss, it's fine, okay? Then the alternate hypothesis would be that the 2014-2015 U of M men's basketball team has a greater ability to win after a win than a loss. What we can see here is that this null hypothesis, this idea is the idea of independence, and the alternate hypothesis is this idea of the hot hand, okay? So we always assume this independence. We assume that the ability is the same, nothing special is happening, right? But we want to see if something special is happening, or something special is this hot hand. And you're going to be writing hypotheses today in homework number 3D. Okay? So just like we have in the past, if we're going to be doing a hypothesis test, what we need is we need a test statistic. Remember that a test statistic is a measure we calculate from performances to use as evidence in a hypothesis test. So in this scenario, it's going to be the difference between the two proportions, okay? So the name of our test statistic is going to be the difference in win proportion or percentage. And remember, we also want to talk about what we are subtracting. So basically, it's the difference in win proportion, what happens after a win, and what happened after a loss, okay? Or you could put winning first minus losing first, or something like that, okay? But basically, those are the two things that we're comparing, is what happened previously, a previous win or a previous loss, okay? And so the value is going to be the win performance after a win, which was 0.529. These are the numbers that we have up here, okay? And then we have the win percentage after, or proportion, after a loss, which is 0.467. And so if I take 0.529 minus 0.467, that gives me 0.062. Okay. And again, I know a lot of us like percents better. So 0.062 or 6.2% is going to be our test statistic, okay? So again, the name of our test statistic is the difference in win proportion, what happened after a win versus after a loss. And the value is going to be that 0.062, all right? So now to see how likely it is to get a difference in performances of at least 0.062 just by random chance, we're going to perform a simulation, okay? Now the explanatory variable was the, like, what happened first. So the explanatory variable is the outcome of the previous game. And the response variable is the outcome of the next game. Because they both have two categories, that means that we can still use our methods from chapter 2 to simulate. And I know that usually in explanatory and response variables, we talk about like experiments, but in this case, it's the explanatory and response variable for this available data situation, okay? We're trying to see if changing the outcome of the previous game could potentially affect the outcome of the next game. Okay, that's what we mean by that. All right, so let's describe how we would use note cards to simulate the situation. Well, we know that we would go to our two-way table, and that can be very helpful. Remember, even though there were 33 games, there were only 32 pairs of data that we were looking at, so we would label 32 note cards, okay? And the outcomes are what happened in the second game, right? So we're gonna label some as winning the second game and some as losing the second game. And in our chart, we see that they won the second game 16 times and they lost the second game 16 times. So we'll label 16 as winning the second, 16 as losing the second. Now our two piles are the different things that we're comparing. And remember, we were comparing what happened previously. So this means what happened first, or if they lost first. And in our table, we see that they won first 17 times and they lost first 15 times. So we'll shuffle and we'll deal a pile of 17 for winning first and 15 for losing first. Again, just recreating that situation. Okay. And then we find the win proportion or percentage for each pile, and then we subtract. Okay. And when we subtract, if it's worded this way, when we subtract, what we're doing is we're calculating the difference. And regardless of which one is bigger, we're always going to take what happened winning first minus losing first, because that's how we calculated our test statistic. What happened after a win versus what happened after a loss. And of course, then we would repeat that many times. Okay. So again, very similar. The only thing that gets a little sticky here is that these, like, they're both wins and losses, but the piles represent for the wins and losses that happened first, and the labeling are the wins and losses that happened second. Okay. All right. So we're not going to do that, however. Oh, wait, hang on. This is very similar to the steps that you're going to have in number 3E. Sorry about that. Oh, and then the test statistic up here, sorry. This is going to be similar to number 3C. Okay, just trying to help you out so that you know where to find those homework things. So test statistic is going to be similar to 3C, and then note cards is going to be similar to 3E. Okay. So we're not going to bust out some note cards and do that. So we're just going to use the difference in proportions applet on the computer, and there were 100 trials that were there. And so we're going to try to find our p-value. Remember, to find the p-value, essentially we look for our test statistic. Remember, our test statistic was this, the value of the test statistic was 0.062. Okay. So to find our test statistic, we're going to see how many values, oops, are at least 0.062 over our total, okay? And let's be cautious about reading the scale, okay? So sometimes it helps maybe to fill in the numbers. So like this 0.1 is like 0.100. This 0.2 is like 0.200. So we can see that 0.062 is going to be somewhere in here. And so I look here, let's see if it goes by 10. So, excuse me, 0.01, 02, 03, 04, 05, 06, 07, 08, 09, 10. All right. So that means that, so here was 01, 2, 3, 4, 5, 6. So this is like 0.060. So 0.062 is going to be just above that. Okay, so read your scale really carefully, and then just above that, we'll include it. So it does look like we're going to include all of these. Remember, it's not just 0.62, but it's everything at or above that 0.62. And we would count all of those dots. Well, there are a lot, which means that this isn't going to be very special. But when I counted those dots, you guys, I counted that happened 53 times out of the 100 trials, which means that my p-value is going to be 0.53, okay? Remember that to find the p-value, we look for the test statistic. Our p-value is not 0.062. The 0.062 is our test statistic. We see how often that test statistic occurred. That's our p-value. And so now what we can do is interpret this p-value. And just like we did before, when we interpret the p-value, we're saying how likely it is to get this, how likely it is to get this test statistic. So we'll say that there is a 53% chance of getting this test statistic. What was the name of that test statistic? Remember that it was a difference in win proportion what happened after a win minus after a loss of at least 0.062. I wrote too big. Just by random chance. okay? And so again, we're looking at how likely it is to get this test statistic. All this talks to us about what our test statistic is, right? So again, this value right here, or like this description is that test statistic, okay? So there's a 53% chance of getting this test statistic by random chance. And this test statistic was the difference in win proportion, what happened after a win versus after a loss. I mean, you could even say like winning first, lost first. You know what I mean? Like something like that, where you're going to be discussing what are the two things that you'd be subtracting, okay? So that's how we interpret the p-value. Again, to interpret the p-value, we always talk about our test statistic and random chance. Okay. And then in our conclusion, we always mention the p-value and if we do or do not accept our HA. Well, that 53% chance was not special, which means that we are not going to be able to support our HA. So our conclusion is going to be that since our p-value of 0.53 is greater than 0.05, and we mentioned that because we want to tell people that's our cutoff for being special. Our cutoff for being special is 5%, and it was bigger than that. So that means that we do not have convincing evidence that our HA is true. And then again, that was that the 2014, 2015 U of M men's basketball team has a greater ability to win after a win than after a loss. Okay, so again, same type of a thing, right? And again, in our, just like in our p-value, we always talk about our test statistic. In our conclusion, we always talk about our HA, okay, right? And this was what our HA was. We said we do not have evidence that that HA was true, okay? And so this is going to be very similar to the last couple. Where is my pencil? Oh, sorry. Okay. So you're going to be finding the p-value in number 3F. You're going to be interpreting the p-value in number 3G. And you'll be practicing a conclusion in number 3H. Okay. So as you can see, very similar to what we did in chapter 2. It's just that our two contexts are always what happened first. Is it after a success or after a failure? And that's a little bit about chapter 3. All right. I hope you guys have an awesome day. Take care.